Joonathan on the stage.
So thank you. As I said, the security around containers itself is actually quite complicated and deep topic, and we could go on for hours here. First on the containers themselves, host security around them, all coming down to monitoring and everything. But just to get started, let's start up. What are the containers themselves, and where they might be useful? So, in a simplified form, we can look at containers as a solution to a problem on how to get software to run, reliability in all the different computing environments that you need the software to run. So the software usually starts off from somewhere from developer's computer. It needs to move on to the test environments, and from there on to production in the end. And in the cases of enterprises, they might have software already running in somewhere in a physical data center, and containers might be useful there to help move these applications to public cloud or even to private cloud in some virtualized form. And then what does the container actually consist of? So container consists of everything needed to actually run the application. And that includes the runtime environment, the application itself, all its dependencies, libraries, other binaries that might be needed. They are all bundled into one single package. And this one single package actually shares the system's kernel with all the other containers running on the same host. And by running containers, you actually gain additional layer of isolation. And then this layer of isolation can help you live safer in your environments. And of course, containers help you to ease the application development lifecycle, make it faster, make it leaner, as you can reliably, hopefully, deploy the same container to all the different environments. Some security benefits that come with containers, and usually with the architecture around the containers, especially if we talk about microservices, are the smaller attack surface area, shorter lifespan of the actual deployed versions, as it allows to go quicker. You fix bugs faster, deploy a new version, and in general we see more automated processes around containers as well. But of course, some of these points can actually be also the negative sides of containers. So smaller surface area can mean that actually you're creating more complex environments. You have more different containers talking to each other. You need to understand the environment and the complexities. Shorter lifespan, and the fact that mostly containers are being used in a stateless form can mean that it's much harder to actually debug what's going wrong with your applications if the containers come and go and you don't have your logging sorted out, for example. And automated processes kind of have similar effect that things can just happen without you being in control in cases where you don't think about those things. And as I said, in most of the cases, containers are considered to be ephemeral and stateless. So when we continue with the talk as well, I don't really necessarily touch any state in these topics. So if we go into container security, then containers actually are making use of quite several technologies that have existed for quite a while. So we start off with building containers on top of Linux kernel namespaces. And namespaces are the components providing the isolation that everyone cares about in containers. We talk about Linux control groups, or C groups as they're called, for resource limitations. So you don't want to have a runaway container consuming all the memory or CPU on your host. C groups come into play there. We're talking about Linux capabilities, and this allows you to fine-tune the privileges that containers are actually capable of using. So here we can limit file system I/O access, for example, or access to raw sockets or anything like that. And also we are seeing more and more containers leveraging even more finer grain kernel securities via AppArm or SE Linux and GRSec and other kernel security modules. And then by today we can say that containers by default out of the box in most of the cases as containers themselves are quite secure. We have we see huge security teams working around Docker, around infrastructure automation tools and Kubernetes and everything. So people are paying attention and are being very sensitive to security issues there. And but the one thing that can change it easily and something that you necessarily need to keep on mind is that if you start running privileged containers, this is easy to change, and privileged containers cause a lot of trouble. So if we talk about container security, we have to touch on the hosts themselves as well, where the containers actually run. And in a simplified form, you can think of the hosts as standard servers as you have been operating day in, day out in your life. You still need to patch these, you need to pay attention to the security, but there are some additional things that can make the environment more secure. You can actually fence off the host as it is totally, and then just leave it available only for some back-end access network where you just can do your administration tasks. You don't necessarily have to give SSH access to all your developers to those boxes anymore and things like that, because usually containers have their separate networks where they sit. As I mentioned before, really watch out for privileged containers. Privileged containers can do pretty much anything that could be done on the host machine itself. So one interesting example here is that within the privileged container, if we talk about Docker, you could do Docker in Docker. So it's a way to go for the inception. And if you're using an orchestration layer on top, for example Kubernetes, and you need to run some privileged containers, whatever it's doing, some security daemon or anything like that, then Kubernetes actually has an admission controller called deny escalating exec, and this actually restricts attaching to the privileged containers and running exec on them as well. So this brings some additional security into the world where you still run privileged containers. Security about images. So images is the easiest way to get something bad into your environment. And if you don't pay attention of where do you get your images from, you can face a lot of harm. So the simplest thing here is make sure that you know where your images are coming from. Hopefully you get them from the private repository somewhere and you have put them there yourself. You can make use of the Docker Trust frameworks and everything like that. But even if with the known images you use, it would be good if you would be using something like Clear or then the Docker Hub is providing security scanning capabilities as well, because these are like statistical scanning tools that take a look at the CVE databases and everything like that, and make sure that your images don't include anything that could be vulnerable. And then CVE database today contains around 90,000 different vulnerabilities and issues. So there's a lot of things that could be happening within your images that you run today. If you are sharing your cluster or the host machines with some other teams, then in cases like that, it might be useful if you actually force your containers to always pull fresh images. And this means that no other can easily make use of the image already existing on your host machine, and then just using that to boot up their own container and so on. And if you're using orchestration layer like Kubernetes, you could also pull in image policy webhook admission controller, and this allows you to do very fine-grained control over the images that you actually would be executing on your cluster. You could take specifically build whitelist, blacklist, or anything you want to do. You can take a look at which Docker image layers are being pulled from where, and then so on. And one good thing to keep in mind with images is that keeping images as small as possible is also good for security, because the software really can't be vulnerable if it's not there. And please don't bake any credentials or anything like that, anything sensitive into your containers and container images, and try to fetch that information separately. Kubernetes is providing config map and then secrets capabilities out of the box. Make use of those, and then please don't put anything into the images. Security of the network. So today it's also relatively simple already with your containers to make use of different network policies. So you can ensure that containers can actually only communicate with other containers that they need to communicate with. You don't need to make container to container to container network wide open within your cluster, because that allows one compromised container to actually make a lot of harm for all the other containers as well. Again, Kubernetes is providing network policy out of the box. Currently that is ingress traffic rules only, but it's label-based and then very easy to configure. And if you are looking for finer grained controls, then Project Calico, for example, is a very good alternative CNI plugin. And to actually secure service-to-service communication, then service mesh tools like Istio make that relatively easy as well, by taking care of, for example, mutual TLS, CA, and things like that. So resource quotas, I briefly touched on this before as well, but this is actually something that people, in most of the cases, actually miss. Out of the box, no one really defines resource quotas. So the container can take whatever resource is available in the host, and by this cause noisy neighbor, or in the worst case, denial of service to other services on that host. And again, Kubernetes actually allows to define resource quota policies on the namespaces that get applied by default. You can use admission controllers to enforce even finer grain resource quotas. And this all actually ties down into the C groups on the kernel level. And one of the most important points here is that plan for the attacks. Hopefully nothing really happens, but if you don't think about this, then when something happens, you're in more trouble than you might be elsewhere. Investigate how would you actually, find out how would you actually investigate potential attacks. Make sure that you're actually logging everything, and then the logs are stored in some central location, and then actually go out properly outside from the containers. Think about whether you can somehow snapshot the problematic containers to actually investigate these in details later. And then make sure that you understand what information actually lives on your host machines, and then within the containers, if you store anything in there, God forbid, but what's your recovery plan for all of that data. So the basic recap around here is that you should really try to prevent unknown images. You should continuously scan for the images for vulnerabilities. I'm pretty sure that you still can find images that have Heartbleed, OpenSSL libraries baked into them. And you don't necessarily even bring that in meaningfully by installing a vulnerable application, but it's just some library that at some point got compiled in somewhere. Stop privilege escalation if possible, and if not possible, use the capabilities around it. Enable only the capabilities that your containers require. So if you don't require allowing file system access, write access, for example, you can actually disable things like that there on the capabilities level as well. Enforce network isolation, so no bad actor on the network can harm your containers. Protect host resources. Encrypt sensitive information, so this means all the credentials and everything, and inject these via other means than baking them into the containers. And enforce use of automation tools. and tie these automation tools into your monitoring system so you understand when actual deployment was made. So you can go back and look what happened after the deployment, and if you're debugging anything, this really makes things simpler. And then by this you provide visibility across the environment, so you know where this specific container image has been used before. You can see whether it was used in test environment, did it see similar effects, or this is now new and happening only on production with this image, and so on. And Center for Internet Security, CIS, has actually put together the benchmarks. Pretty much just a nice word for huge documents that describe how to safely run Docker and Kubernetes in your environments. But the nice thing about that is that now people have built automation tools that help you to validate that your environment actually is built as the benchmark says it should be built. And these usually give really actionable insight, something that you could just go and then change and make your environment safer. So just a few tools for you to use and check out. And yeah, this is it about container security. It's relatively short. We could go on for hours, pretty much on every single slide of this, but I'm happy to take questions as well.
Today is the second talk. We focus on security, so I have to ask.
Sure.
Have you been penetrated? I mean, in a nice way. Like
is there a nice way?
Like, and how deep it was?
Teleport has not been penetrated, and I believe Giles can comment on MoveGuide's history, but
No.
hopefully not.
Thankfully.
What I can comment.
Some attempts. Like, have you mentioned that? That was like initial question.
Teleport has seen
How you
attempts.
mentioned that?
There's always attempts. You can see it in our security alerts and the logs every day. People try and get into the network on average once every 2 minutes, 3 minutes. It's, you know, there are people malicious out there that they're just scanning whatever they can scan. They're trying to do whatever they can do. You have to protect yourself, and you have to be sensible. It's about, you know, I said earlier, making the attack surface as small as possible, and then once you know you have to have that little bit open, protecting that, alerting on it, finding out from the noise what actually matters. And so you do see it day in, day out, that there are people trying to do it.
And there's a lot of like, it's a business on its own to actually scan you and then try to make money out of that. So you can easily see guys from India writing to you that they are willing to provide you some security insight, and they have done some scans on you and stuff like that. If you actually go into logs, you can see what they have actually done and so on. So people are trying to scam that space as well. Yes?
So you mentioned the snapshotting, the malicious or problematic images.
Yes.
For actually Docker containers.
Mm-hmm.
Is like there a tool available, or should I basically scan, look for the Docker storage of Docker images?
You just look at the storage and you just pretty much copy the layers away.
Okay.
Yeah, there's potentially, probably there are some specific tools as well, but they don't really do anything else.
A question here, please.
On one of the slides you mentioned that the smaller the image is the better. So what is the smallest image you can
Smallest image, probably some very tiny statically linked binary that you just execute. So if we talk about Go programs, for example, then Go programs can be compiled into statically linked binaries, and you can pretty much put these into Scratch containers. If you need to talk to some external parties over SSL, you need to add some CA certificates to that as well, but on the average we can talk about megabytes there, depending on the actual application.
But the base image, what is?
Scratch container is pretty much just an empty space. It's nothing. If we talk about like more fully functional Linux, we start getting into the Alpine Linux, for example, and even then it's tens of megabytes potentially.
A question from my side also.
Yes.
You mentioned that you encourage to scan the images you're using from open source, presumably
Mhm.
for vulnerabilities.
Yes.
Well, did you ever have you ever found anything vulnerable from there? Like on your
I
practice?
think
How big of an issue is that?
I can't remember anything because like some of the teleport stuff are really running on Scratch containers and pretty much something very slight but slim. But the Clear project itself, I believe, and Aqua Security, for example, have put together a lot of presentations on these when they scanned the whole public Docker hub, for example, and then just exposed the CV database vulnerabilities, and there's currently like 90,000 CVs available, and the number of vulnerable images was huge.
Okay.
So yeah, please
Were
be
there
aware and take a look.
Were there any, well-known and
I think-
widely used ones also?
I think potentially it really, if people at some point in time have built something on top of Ubuntu or Debian or some of these huge distro images and have just kept building on top of these without upgrading the underlying image itself, there still could be some Heartbleed or Ghost or stuff like that in them.
Yeah, that could be.
And then Clear is a very good open source tool from CoreOS for running those scans. And if you're running, hosting your images on Docker Hub, for example, and have paid Docker Hub planned, then Docker Hub actually provides this as well.
Okay.
So it's really easy to get started with scanning there. There's no excuse.
Okay, that's good to know. There was a question.
Yeah, I have a question. How do you protect your public services and API from DDoS attacks?
So for example, on the Move Guides side, we are using Apigee, and pretty much manage to offload taking care of the DDoS by just using some provided service.
So you basically manually trigger traffic for your
Yes.
DDoS provider in case of the
Yes.
attack.
Yes.
Amazon are actually pretty good at doing it these days. DDoS protection has been on by default standard for over a year now. Amazon came out with a product called Amazon Shield that they actually put in front of most of their load balancers, things like WAF, which is their web application framework. So anything that you can potentially put out to the outside world via Amazon will now be protected by Shield.
Yeah. And
Not
then
exactly, because if there will be targeted attacks on your API calls, for example, they will find out what is your heaviest API calls and just issue a specific number of them. They could easily take down your service, and it will be not DDoS attacks on Amazon level.
But this is something you enable the throttling on the API gateway side. So this is something that the API gateway, and as Giles mentioned in his first talk, choose your API gateway wisely, and that this is exactly the reason. Yes, you could be running your own API gateway, you can build something on your own, but if there's some service that can offload some of that pain from you, then
You have to. I mean,
makes
we
sense.
mix this Apigee and WAF together to find the best blend when it comes to opening the APIs up, and they all have this DDoS protection, rate throttling, everything you need.
So you actually had DDoS attacks?
during teleport days, we have seen heavy traffic that can be considered DDoS attacks. Yes, in most of the cases, there are not really been just to harm us, but people, for example, crawling data at rapid rates and stuff like that, because teleport public APIs contain a lot of information that we're not really restricting. Then some of our competitors and people just out of the interest have gone out and crawled that at very high rates, and that can cause some issues.
What's the best practice for any application that needs a virtual machine like a Java or Python or Ruby or whatever? Do you bundle the virtual
VM,
machine itself in the image, or
yes,
yeah.
VM goes into the image. There's no sane way to share the VM
So
as such.
how is it usually, or whose responsibility is to keep the VM up to date in that case?
So ideally for the application there will be base image provided that already has the VM in. So usually it's still the developers themselves, because they know which Java version, for example, they need. they actually build the final images. So they need to keep their base images in line with what they require. And all the security, vulnerability scanning and everything like that, that should happen quite transparently for them. They should be aware what's happening and if they have any vulnerabilities, or even if they accept some of the vulnerabilities. But someone else shouldn't be building the images for them.
I remember by CoreOS there was also a container registry service. I can't recall the name.
Yes, I can't remember the name by heart either.
But
They have the
I-
clear capabilities built in.
and they also, it was over a year ago, I think, and back then I remember they also offered the security checks on your images.
Yes, it's pretty much the same clear that they have provided as an open source. It's built into their platform offering as well.
Do you have any experience passing security audits with containers?
Not yet. At Skype, we did somewhat pass some security audits with containers, but that was containers, but purely on the LXC front. So Docker was not still a thing back then.
Okay then, guess that's it for tonight. Thank you so much.
Thank you.